Hi, good afternoon. So today we're going to discuss a way to factor quadratics using a method called the Berry method. The Berry method is one of my favorite ways to factor quadratics because even though there's many different methods that you'll probably learn in your math class, if a problem can be factored, or if a trinomial can be factored, the Berry method works every single time. Some of the other methods you might learn in your math class, certain ways work better depending on how it's set up, depending on where the numbers are in your trinomial. But this way works every single time, if it can be factored. A lot of students enjoy this method because there's kind of steps to it that they can follow. There's a process to it, and they're not really doing a trial and error method when they go into factoring. So our first trinomial today is 3x squared minus 2x minus 5. The first thing that we're going to do, and we always do this no matter what method we're using of factoring, is look for and see if there's a greatest common factor. And right here, we don't have a greatest common factor because we don't have any certain number that goes evenly into all three numbers. So we can't factor anything out of all three yet. Step number 2, we're going to make a mistake. Some of you are probably thinking, I got this part down pat. I'm really good at making mistakes in math class. Well, we're going to purposely make a mistake today. And here's the mistake we're going to make. We're going to take our trinomial. We're going to set up our parentheses just like we normally do when we're factoring anything. But now we have a 3x squared out in front. We're going to take that 3x and put it in the beginning of both binomials. Now, right away, you're looking at it going, well, that's a mistake. Because if I FOIL it, 3x times 3x is actually 9x squared, not 3x squared. So we made a mistake. But don't worry, we're going to actually fix our mistake at the very end. We made it on purpose, remember. Next, we're going to multiply a times c, the a value times the c value. So our a value is always up in front of the x squared. We're going to multiply that times my c value. And that will give me negative 15. Because 3 times negative 5 is negative 15. Next step, we're going to find two numbers that when we multiply together is going to equal negative 15. But when we add them together, it's going to equal b. Kind of like we did before with basic factoring, where we had to find two numbers that multiply to give us c and add together to get b. But this time, we're actually multiplying a and c together to get a different number that we need to find two factors of. All right, so two factors of 15, or negative 15, are 3 and 5. So we're going to place them in as our other numbers. Now, they have to multiply to give me a negative 15, so one of these has to be negative. And if I add them together, I need a negative 2. Then the larger of the two numbers is going to be the negative, and the smaller is going to be the positive. Now, you might think we're done, but don't forget, we need to fix our mistake that we made earlier. So here's how we fix our mistake. We're going to go back and look at our binomials. We're going to see if we can factor anything out of either one of these binomials. If you made a mistake, you got to factor it out of at least one. Sometimes you actually do two of them. So if we look at this very first binomial, it says 3x plus 3. Can we factor anything out of here? Yes, we can pull a 3 out of this first binomial. So if I pull a 3 out, that leaves me with x plus 1. I can't factor anything out of this other one, so I'm going to leave that one alone. 3x minus 5. Now, since this was a mistake, it's not part of our answer. We can actually get rid of it and cross it out. We don't need it anymore. So really, or we can even erase it. So this would be our final answer. This would be this binomial factored out. And if you want to check your work, you can always FOIL. So 3x times x is 3x squared. If I did the outside, I would get negative 5x. The inside is 3x. Add those together, I get negative 2x. And 1 times negative 5 is negative 5. It works out every time. All right, let's try another one. We'll do a few examples today. And remember, they have to be able to be factored. That's why I had to write them down. I got to make sure I'm just not randomly putting numbers up on the board. All right, so 2x squared plus 11x plus 5. All right, no greatest common factor. We're going to make our mistake like we did last time. I'm going to put a 2x in front of both. We made our mistake. We're going to multiply a times c. 2 times 5 is going to give me 10. Now I need two numbers that multiply together to give me 10, but add together and give me 11. That's simple enough. It's going to be 10 and 1, because 5 and 2 would not work to get 11. Everything's positive, so both of these are going to be positive. Now I need to go fix my mistake. Like I said, most times you're just going to be fixing one binomial. There's a rare chance you actually have to fix both of them. All right, so I can pull a 2 out of this first one. That will leave me with x. If I pull a 2 out of the 10, that leaves that at 5. I can't do anything with the second one. Since that's a mistake, we can get rid of this. We don't need that anymore. And then this would be our answer. We just factored it. All right, now let's see one that has a greatest common factor. All right, let's do 9x squared plus 66x plus 21. All right, so this one's going to have a greatest common factor. 9 is not the greatest common factor like we did in our last video. However, because 9 can't go evenly into 66, 9 can't go evenly into 21. However, a 3 can go evenly into all three numbers. So if I pull a 3 out of the first one and actually factor a 3 out, I'm going to create a brand new trinomial. So if I pull a 3 out of the 9, I'm left with 3x squared. If I pull a 3 out of the 66, I'm left with 22x. If I pull a 3 out of the 21 or factor it out of the 21, I'm left with plus 7. So that was the first step. We had a greatest common factor. Next, we're going to make that mistake. Now, this 3 is part of factoring it out. So we have to leave the 3 there. This wasn't us fixing a mistake. We have to leave it. So I'm going to leave a 3 out in front. I'm going to use my 2 parentheses. And since I have a 3x here, I'm going to put 3x in the beginning and a 3x here. Remember, this is a mistake we're making, and we make it on purpose. Next, I'm going to multiply a and c together. Well, change color so it stands out more. So if I multiply 3 and 7, I get 21. So now I need two numbers that multiply together to give me 21, but add together and give me the b value, which is 22. Well, 7 and 3, but that's not going to give me 22. So I'll use 21 and 1. Because I can add those and get 22. So since everything's positive, that makes that part easy. Now, even though we have a 3 out in front, don't forget we need to fix our mistake. I can't pull anything out of the 3x plus 1. But I can pull a 3 out of here because the 3 goes in the 3 once, and a 3 goes into 21 7 times. So let's rewrite this. I need my original 3. I'm going to pull another 3 out. I'm just going to kind of put it up here for now because I'm going to erase it. If I pull a 3 out of a 3x, that leaves me with just x. If I pull a 3 out of the 21, that leaves me with 7. This doesn't change at all because there's no greatest common factor in that binomial. So then I get 3x plus 1. This little guy that I'm using to fix my mistake, I can get rid of him. He's gone. So here is my final answer. And once again, if you want to check this, you can always FOIL your binomials. Then once you FOIL your binomials, you'll end up with that trinomial right there. And then get back up to the first one, you just have to distribute the 3 back in. All right, if you guys have any questions, please leave a comment or question below. Give me a like. Please subscribe to my page for future videos. If you have any things you want me to go over or cover in one of my videos, just please email me or leave that down below. All right, have a great day, you guys.